Okay, so I'm going to go ahead and read through the specification, and then we can kind of see if we can work through the logic. So you have a friend that you used to play rock, paper, scissors with quite often in person. However, they recently moved away from you, and for the sake of nostalgia, you decide that you want to play again asynchronously over the computer. So the key here in this first part is that you're playing with another person. So you're not playing with the computer. So in other words, both users will make a choice, and so you'll have to simulate both users rather than just the computer and one user. So slightly different. What's up? Oh. So yeah, slightly different than we've set it up before. So the computer application should be designed so that both you and your friend can choose rock, paper, or scissors, and the computer decides the result of the game and returns it as output. Okay. So again, I can't do the flowchart directly, but what we can do is work through some pseudocode that we can then put into action. So let me go ahead. I'm going to pull up a Notepad document. So what, and I'm going to ask from you guys, what has to what has to happen first before we can decide the result of the game? Have you guys played rock, paper, scissors? I guess I should start there. Have to know the inputs. Yeah, so, and maybe I jumped the gun here, but yeah, so basically what Naeem is saying is correct. We have to know the inputs. So if you're doing this in person, basically you'd have two users, and user one would say rock, paper, or scissors, which again, this is not the notation for the flowchart, so don't get confused by that. The second user would have to also make their choice. So you're probably going to need at least two variables so far. So you need a variable for user one's choice. You will need a variable for user two's choice. And after that, so once you know if it's rock, paper, or scissors on either side, well, what happens next? How do we determine who won? So let me ask you a couple of options. We need to add what beats what. Okay. So let's let's make a list of all the different possibilities. When I was talking about the decision making, and I'm sorry my voice is kind of shot today, but bear with me. When you're thinking about writing a program, you really need to consider all the different cases that are possible. So, user one can pick rock, paper, or scissors. User two can pick rock, paper, or scissors. We have to manually go through and figure out all the different possibilities, because it is a finite set of possibilities. And you can get kind of clever with some of the flow charting and mapping the decisions to sort of eliminate some of the choices. But, oh no, I think that's on your end. Check your settings. Okay, thank you. And it is being recorded, so. Okay, so what are our possibilities? So first, hold on, let me back up. First thing, we need to have user input for both. Let me say this, have both users input. So we kind of simulated that. Now, so what is it? It's rock, let's see, so rock beats scissors, paper beats rock, and scissors beats paper. I think that's the order of determining who wins. So yeah, so what I want to do at this point is write down all the different cases. So given this is just information, we're now going to map out all possible cases of user 1 and user 2 choice. And, in the flowchart, you'll be using whatever variable you chose on each user side to make the mathematical comparison, or I guess the equality. It's not really math, but. Okay, and as a side note, you can choose to use a number if you want instead of a word for the choice of rock, paper, scissors, but you can use a word too. So, you can check to see, okay, is user 1 equal to rock? Is user 1 equal to paper? And so on. Okay, so, but I think in this case you're going to need to use, this will be the hint, I think you're going to need to use and to make things easier when you're checking. So use the Boolean operator and to check cases. That will simplify things a good deal. Okay, so yeah, we have a lot of cases. So user 1, let's do picks rock, and user 2 picks paper. This is going to be tedious. That's kind of the point, I guess, is to show you, you really have to map out all the different cases. To make it simpler, what I'm going to do is just write rock for user 1, I think 3 times, right? User 1 picks. So if user 1 picks rock, there are 3 options for user 2. So user 1 picks rock, so we got rock, paper, rock. Let me just copy this down. So user 2 picks paper, picks rock, or picks scissors. So that's one set. Move to the next set. So user 1 picks paper. So there's going to be 3 choices for that. And, well, we won't have repeats because there's 2 unique users. I think that's what part of the challenge is here, is that you have to sort of note to yourself that, okay, I have more cases than I think I do because of the 2 separate users. I'm not sure if that made sense, but hopefully. And yeah, if you have a question, just feel free to say it out loud. Okay, so the next round, so user 1 picks paper, and then we have all of the user 2 choices, so paper, rock, and scissors again. And then finally, if user 1 picks scissors, and user 2 picks paper, rock, or scissors. Is there any... it looks like 9 cases. Can you think of any other cases? I think this is comprehensive. Slash, does this make sense? You kind of see why it's important to figure out what all the possibilities are. That this is really the crux of the problem. All the possibilities. So, yeah, these are all the possibilities because you have, so user 1, regardless of what they pick, you've represented all three cases that user 2 could pick. My follow-up question is, so there are 9 cases. Is there a way to eliminate, can we reduce this to 7 cases? So can we reduce to 7 cases? I'll just pose that question and see if you can figure out what I'm kind of getting at. Because 3 of the cases can be checked in one statement. Let me kind of reorganize this a little bit and see if it pops out to you. So we have 9 cases. We're seeing if we can get this down to 7. Let's see, Yuvaraj says, if user 1 equals user 2, then it's a tie and you go to 7 cases. So yeah, so exactly. And this is not a requirement of the assignment, but I wanted to point out, since we were going through all the cases, that these 3 cases could actually be reduced to 1. So you don't really need to check if user 1 and user 2 are equal, then it doesn't matter what the choices were, it's just a tie. And so that would default to just an output that would say, okay, they both picked whatever and it's a tie. So does that make sense? And hopefully I'm not going too fast. Got it. Okay. Yeah, so again, the I started reading some of the Errortown posts, which I'm pretty happy with how that's going. I'll probably take some time to summarize what you guys have said. But somebody stated that, you know, for rock, paper, scissors, well, for all of them, the specifications were quite simple and straightforward. But then when they actually got into working it out, they found that it was more, you know, involved than they thought it was going to be. And yeah, that's one of the takeaways that I kind of want you guys to have working through the flowcharts. It becomes so tempting when you're coding to kind of gloss over the things like this, where, you know, you have to think through all the cases, and you start to kind of just type. And yeah, so the purpose of going through this is to help you really separate the problem-solving process from the code writing process. Because when you, not to say that you can't ever combine them, but it helps, certainly if you're a beginner, to sort of take a look at them separately. So, yeah, so from here, so user 1 made their choice, user 2 made their choice. We determined, and again, you can use 7 or 9, it doesn't matter. We determined how to write all the decisions needed to either say, well, I guess let me ask you. So in the end, how many possibilities are there for output? So what kinds of output are we going to share after this? What do we need to know at the end? It's the last step. So last step, we're sharing the results. So what are What are the possibilities for the results? Give me one or two and I can start writing them out. So user one, yeah, exactly. So user one wins, user two wins, or it's a tie. And so what you'll see is there are different cases that will lead to each of these results. But let's see. So our results, we have that user one wins. We have user two wins. And we have it's a tie. So to get to the output, what you need to do is then go through each of the cases and see which case leads to which output and kind of map it accordingly. And there are some shortcuts. There are more efficient ways to do this than others, which again, I'm not really asking for in this case. I just want you to be able to think through it. But if you're able to get, kind of the long form, maybe start thinking about how you can shorten it up just for your own personal benefit. So let's see. So we kind of already marked these at the top that all three of these were going to be a tie. So let's see. So paper beats rock. I'm going to try to put the user one wins here. Okay, so rock beats scissors. Paper beats rock. And scissors beats paper. Okay, so we have these three possibilities. Isn't that nice? We had 9 cases and 1/3 of each of them lead to one of the outcomes. So let's see. So this is user one wins. And then this one, user two wins. And so the last step is to share the result. That'll come from your cases. And like I said, you can obviously write, you can write 9 decisions if you want to. You can also try to limit it so that there are fewer decisions to get to the same outcome. And you can either layer Boolean operators like and or to do that. Or you can figure out how to nest the decisions accordingly. But I believe this should get you from start to stop. So any questions now that we've kind of walked through in a human way what the process is for 2 users playing rock, paper, scissors? Okay. Some satisfaction. If anybody else has a follow-up question, let me know. Otherwise, I can talk about some other things. And I will post this. I'm not recording through Blackboard. I'm recording through OBS, which is what I use to make my videos. So it'll take a little extra time to get that going, but we'll put it up. And just as a reminder, there's no repetition in the first assignment. It's just purely decision making leads to an outcome and you're done. Wanted to keep that pretty simple. Okay, and I can always come back. Scoot this over here. I think what I will do, I'm not going to address the first one, but we can talk about the second application in the same way. And then just basically I'll see if there are any other questions, and I think we can conclude after that. So that's probably the bulk of what questions you may have had. Go ahead and save this. Okay, so this one's a little, this is actually the one that in the Errortown post someone was saying, you know, it looks really simple, but it's a little tricky when you get down into the details. So let's read it first and then start to go through it. So this is loves me not. So consider the process of pulling petals off of a daisy to determine whether someone loves you or not. So a daisy is chosen, and each time you pull a petal, you say she or he loves me or she or he loves me not, in that order, starting with the first petal and ending on the last available petal on the flower. So the computer asks, and the user reports how many petals their daisy has. The computer should then tell them whether or not the result will be she or he loves me or she or he loves me not before any flower petals are removed. So one of the, I guess, issues here is that we're not going to actually go through the process of taking the petals off. All we want to know is, okay, I have a flower. Based on information given to me by this flower, is it going to be the result of she or he loves me or loves me not? We will later revisit this and pull the petals off using repetition, but we're not quite there yet. So the key here is you got to figure out what information does the flower have that will allow you to figure out the result. And if you know what it is, you can feel free to share. Yeah, so name says how many petals the flower has. So, and that's in fact, that's really the only information we have. So the computer asks, the user reports how many petals their daisy has. So let's start there, and then we'll follow up to see exactly how we're going to figure out what the result is. So prompt for number of petals and get input. So in other words, you're going to need a variable to store the number of petals on the daisy. And then I sent out that hint yesterday about the mod function. And that is really the key here. So, but before we get there, how do I know? So, when will the result be loves me, and when will the result be loves me not? Let's start there. So don't give me a formula, just tell me, like, are there cases where it will be loves me, and are there cases where it will be loves me not, based on the number of petals on the flower? Let me go through it a little bit. So here's our daisy. So let's say we have a daisy with 5 petals. So the 5th petal I pull off, I say loves me. The 4th one I pull, it says loves me not. Pull the next one, it's going to be loves me again. The next one is going to be loves me not. And so the result will be loves me. Let me just do this with my hands as well. So loves me not, loves me not, loves me. Okay. If I have 4 petals, so loves me, 3rd petal is loves me not. down to 2 petals, loves me. Last petal, loves me not. So there's really only, there's only 2 possibilities. And I'm trying to figure out what overarching characteristic about the number of petals is in play, whether I get loves me or loves me not. The base case here would be, so if I have 2 petals, it's pretty simple, loves me not. And if I only have 1 petal, I get loves me. Is there something in common between these 2 cases here and these 2 cases here? Because I get the same result. I get loves me for here and I get loves me not for here. Anybody? Okay, and I know this would be a little different if we were in person. Baki says odd and even. She's absolutely right. So yeah, so if we have an odd number of petals, we get loves me. And if we have an even number of petals, we get loves me not. Now, I've had people in the past just say, okay, if it's an odd number of petals or even number of petals. And I suppose if pressed, I might take that. But I would like to encourage you to, there's a mathematical way that we can determine whether or not the variable is even or odd, the value. So, but first let's just check. Everybody see that? So regardless of how many petals the daisy has, if it has an even number of petals, you're going to end up with loves me not. If it has an odd number of petals, you're going to end up with loves me. So just make sure you can see why that's the case. And then, yeah, let's talk a little bit about this mod function that I sent you. What with what we are starting also matters. You mean the number of petals? Because if you mean possibility, it always precedes loves me not. So there's never going to be a case where you start by saying loves me not. So hopefully that makes sense. It's always going to start with loves me, but I do agree with you in the other case. Yeah. So yeah, we can assume that it's always odd that leads to loves me, and always even that leads to loves me not. That would actually complicate things. But good call. So let's talk a little bit about the mod function. So in programming, it looks like this. It is the %sign. And it comes up in use every once in a while. It works really well in this problem. So because it is it's an operator that returns the remainder of dividing one number by another. So for example, and I'm going to read this out loud in this way, just like I put in the email, that so 2 mod 2, you can write it like that or use the %. 2 mod 2 is going to be equal to, anybody? What's the remainder of 2 divided by 2? So in other words, so 2 divided by 2 is equal to 1. 2 mod 2, okay, so let me make sure you guys understand this. So 2 divided by 2 equals to 1. 2 mod 2 gives you the remainder of this division. So if I were to write this out in long form, like, I don't know how long it's been since you guys have done this, but so 2 divided by 2 gives you 1 with the remainder of 0. So the mod function 2 mod 2 gives you simply 0, actually, it's not 1. So it returns the remainder of the division rather than the actual answer. So let's do a couple more examples just to make sure you guys get the the gist of it. So 2 mod 2 is 0. What about 3 mod 2? So what is the remainder of 3 divided by 2? Yeah, so 3 mod 2 is actually going to be 1. Because 3 divided by 2 is 1 remainder 1. And I can kind of continue in this fashion. I'm using the number 2. I'll be honest, I don't remember what the technical term is for the second number in dividing something. But regardless, I'm using 2 because we're talking about even versus odd. And if I want to know if something is even or odd, if I divide by 2 and I get no remainder, I know it's what? If I divide a number by 2 and I got nothing left over, is it even or is it odd? Let me type that out. So if I divide a number by 2, what kinds of numbers give me no remainder or remainder 0? And then same question, if I divide by 2, what kind of number give me remainder of 1? Let's back up to the first question, see if this is making any sense. So if I divide a number by 2 and I get no remainder, what property does that number have? Based on what we just talked about. So I'm looking for basically, is it an odd number or is it an even number? So if I get no remainder, yeah, exactly. So if I do mod and I get 0, I know that that's an even number. If I get a remainder of 1, I know that that's an odd number. And so basically I have a direct mathematical way of telling whether or not a number is even or odd. All I have to do is take that number and use a percent sign or say mod 2. So in this case, if Daisy Petals, which is not a real variable name, but if Daisy Petals mod 2 is equal to 0, then I have an even number of petals. And if the number of petals mod 2 is equal to 1, then I have an odd number of petals. And based on that result, I can then give my final output, because the final output is not even or odd. The final output should be, are you going to get loves me or loves me not? So we actually already figured this out, that if we had an even number of petals, we were going to get loves me not. And if we had an odd number, we were going to get loves me. So I kind of didn't do this in order, but this is the crux of the logic right here. So if you can get there, then you can get the result. Basically, you're going to ask the user how many petals the daisy has, use that mod function to figure out if that number is even or odd, and then return the result. So you're looking at two different possibilities here. So you'll just have the simple dual alternative selection structure. Just like the donuts problem, actually. So, questions about that? Does that make sense? Help you get to the solution? It's funny because the flowchart structure is actually, yeah, it's equivalent to the donuts example. It's a very simple structure. It's just that the math is a little bit, thinking about how to get to the result. The problem solving piece is a little bit more involved. So, which had nothing to do with coding at all, which I know I keep banging on that drum, but it's a really important thing to make note of. So, questions? We okay? Is this helpful? Somebody give me some kind of feedback just so I feel better. Is this all right? Yes, clear. Okay, thanks, Shivani. If it's not, let me know. I can try it again. But yeah, the key here is you need to know how many petals, and then if that number is even or odd, we have a mathematical function, or operator, I should say, that gets us there in one go. So we can make our decision based off of that and provide the result. I will say so, because we're going to revisit this where we actually simulate pulling the petals off. The even and odd cases flip in that case because of how our counter is going to be set up, because we're going to stop at 0 instead of 1. So just a heads up that that's going to be flipped. It's going to be the opposite. Okay. All right, yeah, I don't think I'll go through... The only thing I'll say about the first one is if you don't have a formula for converting Fahrenheit to Celsius, just go Google that. Just look it up. And once you get that formula, you should be able to figure that one out. This is similar to the compound interest problem, because it's just basic computation. This one's similar to the donut problem, and then this one's actually similar to, what was the case example that I gave? It was, I'm blanking. I used to do a hotel example. It was the case example in the video. I can't remember exactly what it was. I think, it was grades. Grades. Yeah. We have to know what user 1 and user 2 picked. So you're going to basically ask, okay, user 1, rock, paper, or scissors. They're going to pick rock, paper, scissors, and you need to capture that using a variable. Same thing with user 2. So user 2 will be asked to put in rock, paper, or scissors. And again, you don't have to use the whole word rock, paper, or scissors. You can reduce that to like an R, a P, and an S or something, if that makes more sense for you. But we're also going to need a variable for that, for the user 2 choice. So far we've got 2 variables, one that holds user 1's choice and one that holds user 2's choice. Actually, I think that's all the variables in this one. All you need to know is what those 2 choices are. Because then to get to the result, which is either, okay, user 1, 1, user 2, 1, or it's a tie, you're just comparing the possibilities for user 1 and user 2 based on how rock, paper, scissors works. So, and I'll go through these, but are we okay up to this point? That first you just need to get the 2 choices? So, yeah, so get the choices, and then there are 9 possibilities. So, and they are listed here that either, user 1 picked rock, paper, scissors, and user 2 picked rock, paper, scissors. So there are 9 cases. There are 3 cases in which user 1 is going to beat user 2. So that would be user 1 is rock and user 2 is scissors. User 1 is paper, user 2 is rock, or user 1 is scissors and user 2 is paper. Same goes for if user 2 wins, these would be the choices. And then if they are equal, then it's a tie. So in terms of the flow chart, you're just going to have a bunch of decisions similar to the grade example in the video that are a case statement. So you'll have a decision leading into a decision leading into a decision. Basically, okay, well, is user 1 equal to user 2? If that's true, then I just relay that it's a tie. If that's not true, then I start checking the other cases. So you could make it real simple and just check all these cases, all these cases rather, when user 1 wins, and then give, okay, user 1 wins. And the only other possibility is that user 2 won, so you could use a really big decision to do that as well. Okay, great. Yeah, so the trick here was figuring out all the different possibilities that would lead to either user 1 win, user 2 won, or that it was a tie. Okay, so yeah, so I'll open it up to general questions. I can work through previous examples, but if there isn't anything else, I'll probably close. So yeah, just speak now if there's something else you would like to see. I've never taught this online before, so it's kind of a new situation. I'm used to being able to, you know, work in the classroom, see what's going on your end, and kind of step in if needed. So a lot of the testing kind of has to come from you, which I'll remind you, I know it's not coding, so you don't have a compiler to give you feedback or to see things run, but you can still test your flowcharts. You just have to, start at the top and kind of move either with your cursor or your finger through the flow lines to figure out, is this working properly? What happens in this case? What happens in this case? And that for each decision point, you actually test each side. So that, for example, if I were testing my daisy flowchart, I would start at the top, I'd get the number of petals, and then I would simulate me being the user. I'd pick, say, okay, my flower has 7 petals. I would then move to the decision point. The decision point has the mod function, operator in it. I would test, okay, well, 7 mod 2 is 1. So that's going to lead me to, based on how I set it up, either the true or the false branch. I just need to make sure that it's on the right side. That it gives me the output of loves me. And then I would test the other side. I'd pick like, okay, I have 8 petals or I have 2 petals, and make sure that I'm getting the result that I want. So you can test the flowchart. You just, it's a mental exercise. But it's just as valid as, the computer running through it itself. Okay. Well, if there's nothing else, I will process this recording and throw it up on Blackboard. And if anything else comes up in the meantime, feel free to send me an email. So thank you guys so much, and I'll see you for repetition. Round 2. We'll probably have another session like this for the next assignment, and I'll let you know when that is. So let me go ahead and stop.